Now, I continue the another problem. Now in this problem, let us see. A man is 48 meters behind the bus, which is at rest. So a man is important one. A man is 48 meters behind. 48 meters behind the bus, which is at rest. Don't remember this point, which is at rest. The bus starts accelerating at the rate of, the bus starts accelerating at the rate of 1 meter per second. Accelerating at the rate of 1 meter per second square. At the rate of 1 meter per second square. 1 meter per second square. At the same time, the man starts running with uniform velocity 10 meters per second. At the same time, the man is running with uniform velocity 10 meters per second. 10 meters per second. So what is the maximum time taken? We have to calculate the time. What is the maximum time taken? What is the maximum time taken? What is the maximum time taken in which the man catches the bus? What is the maximum time taken? What is the maximum time in which maximum time in which the man catches the bus? The man catches the bus. The man catches the bus. That's the question. So what happens here? A bus will, so whatever the question will be there is just a simple diagram to be drawn. So here a man will be there at the point A. So at the 48 meter distance bus will be there. So this is the 48 meter, bus will be there. So here bus will be there. Now what is the distance between man and the bus? 48 meters will be there. 48 meters. Now, what happens? The bus will be stopped. So then he saw it will be at rest. At rest means initial velocity will be 0 at first. So two cases to be considered. In first case, initial velocity to be taken as 0. Then in second condition, what happens? He moves with 10 meters velocity. So the bus will be accelerated with an acceleration A is equal to 1 meter per second square. The bus will be moves and passes. Okay, and moves and passes. This distance is not given. This distance is not there here. This distance to consider as x. Now total distance from man to when he catches the bus will be taken as 48 plus x. But in this initial velocity will be taken as 10 meter per second. Here initial velocity will be taken as 0. Why? The bus is at the rest position. That's why to consider. So it is considered as case 1, and in this to be considered as case 2. By applying that, we can calculate the total time. So what is the time taken to catch the bus? So in first condition, 48 meter distance, a man is standing behind the bus is at the condition at rest position. Then in this condition, we have to calculate the distance. So for bus side and here for man side, both conditions to be considered. For bus side to be considered as distance will be covers only x meter distance. That x value I calculate here. Man side total distance covered will be 848 plus x. So here case 1 to consider from man side for bus side. For bus we calculate the distance at first. Here in this, what is the case here? Bus starts from rest. So the bus starts from rest. So u is equal to 0. And what is the acceleration of the bus? 1 meter per second. Acceleration of the bus. Acceleration of the bus is taken as 1 meter per second square, and time taken will be t. Time taken is equal to t. We have to consider. Now distance covered. Distance traveled by the bus s is equal to consider as x. Substitute in the equation s is equal to ut plus half at square. By substituting this value, what you get? X is equal to u0 into t plus half a into 1 into t square. Then what you get? X is equal to half t square. You get x is equal to half t square. This is the equation 1 you have to consider. This is for what is the condition for bus side. Similarly, to consider for man side. So for man side, what is the distance covered? And what is the time taken? All the things we have to calculate, same things. So case 2 to be considered for man. For man side, what to consider? What do you consider here? Initial velocity. Initial velocity of the man will be initial velocity. U will be taken as 10 meter per second. So 10 meter per second velocity he will be proceed to travel. Now acceleration in this condition, his acceleration will be 0. In this case his acceleration will be 0. He starts with acceleration a is taken as 0. Distance traveled. Distance traveled is equal to s is equal to 48 plus x. Now time taken. Time taken is equal to how much? That you have to calculate in this question. Now here, same values to substitute. S is equal to ut plus half at square. Yes, 48 plus x is equal to u 10 into t plus half into a into 10 square. All this becomes 0. Then what do you get? 48 plus x is equal to 10t. Yes, 48 plus x is equal to 10t we get it. Now let it be equation number 2. This considered as equation number 2. In this, x value to be substitute. To substitute x value. So substitute 1 into, what do you get? 48 plus 1 by, what is the t value? Half, no? So 1 by 2. 1 by 2t is equal to 10t. Get take LCM. 2 is LCM. Here 96 plus t is equal to 10t. 96 plus t is equal to t square, no? X value t square, now t square, t square. Now what do you get? Send to that side. 96 plus t square is equal to 20t. To write all this in order, t square that comes here minus 20t plus 96 is equal to 0. Now to make factorization, to take the factors for this. So 96 factor. So 96 means 12 8s up. For this 96 to take the factors, what do you get? Minus 12 minus 8. So you get minus 20. Yes. So t square minus 20, t square minus 20 minus 8t plus 96 is equal to 0. Plus 96, sorry. 8t 80 plus 96, 12 minus t plus 96 is equal to 0. Now this take t as common, t into, what do you get? T minus 12, t into t minus 12. In this case take minus 8 outside, minus 8 into t minus, plus into minus, minus 12 is equal to 0. Then what do you get? T minus 12 into t minus 8 is equal to 0. Yes. Now what is that meaning? T minus 12 is equal to 0 or t minus 8 is equal to 0. That means what the time taken to consider in this case, t will be total time. Time will be, what happens here? Time will be 12 seconds, and in this case time will be 8 seconds. That means either 12 seconds or 8 seconds time he catches the bus. So he will catch the bus within 8 seconds or 12 seconds he catches the bus. Okay. So this is about one of the problem by considering a man. Once again I repeat here to observe. A man is standing here. So here a man will be there. He moves. Here one bus will be there. One bus. So what happens? The bus is at rest. U is equal to 0. Then what happens? The bus will be starts with an acceleration. The bus will be starts with an acceleration 1 meter per second square, and it moves certain distance. The distance is 80 meters. Now here the distance will be 48 meters. At first from man to bus. Then again the bus moves with the x meter distance to be considered. Now then man starts to move 10 meter per second velocity and he catches the bus at one point. Now what is the time taken to catch the bus by the calculator? So for considering that, we can make two equations and factorization method we have to use it. For calculating this factorization method we have to apply. By the factorization what you get? For man side and for bus side you have to take two equations. You have to consider first x value, distance value to calculate what the distance covered by the bus to calculate x value. Then for man side, s is equal to, what do you get? Equation 48 plus x plus, and the velocity will be 0. Velocity will be travels, and acceleration is also to be taken as 0. Okay, 0 acceleration it will be moves. Then we can calculate after that factorization, we get the factors we know. So you can add this to get this value, multiply this, we can get this. By making factorization, we get t is equal to either 12 seconds or 8 seconds. So within 12 seconds or 8 seconds he catches the bus. So that's this problem. Okay. Then next problem to observe. In this case you have to see a car travels from rest with constant acceleration a for t seconds. What is the average speed of the car of its journey if the car moves along a straight road? So one car will be moves in a straight road, a car will be moves in a straight road. So another question to be considered. A car travels from rest. A car starts from rest and not travels. A car starts from rest with a constant acceleration a. A car starts from rest with constant acceleration a for t seconds. For t seconds. What is the average speed of the car? Question will be what is the average speed of the car? What is the average speed of the car of its journey for its journey if the car moves along a straight road? If the car moves along the straight road, so in one straight road the car will be moves with an acceleration a with initial velocity is equal to 0 in time t. Or calculate the average speed. So here car starts from rest means a car starts from rest. So initial velocity u is equal to 0 and time taken will be t. So time taken will be t and acceleration is a. Then average speed is equal to how much or have to be calculated. Distance traveled in a straight line is given no. So distance traveled will be s is given. S is the distance. So acceleration a with travel s distance. Then all will be substituting s is equal to ut plus half at square formula to substitute first. Now 0 into t plus half into a into t square. And what you get? S is equal to half at square. That is equal to half at square. What is the formula for average speed? Average speed is equal to distance traveled. First we make question 1. Then here I calculate average speed is equal to how much? Average speed is equal to total distance. Total distance is half at square by time taken is t. That is equal to half a t square by t. So t square gets cancelled. Then average speed is equal to half a t. So half a t is its average speed. Okay. So first average acceleration of the car will be a. Initial velocity u, time taken t. Then s to calculate first. S is not given. That's why s to calculate. S you get half a square. Then average speed, what is the formula? Total distance by time. Total distance covered is half a square. By time taken will be t. So half a square by t. Now square t gets cancelled. Now average speed of the car will be half a t. We get it. Okay. Then continue the next class.